Hello students, in the last lecture about the coordination compounds, that is IUPAC nomenclature, how to write the names of coordination complexes, coordination compounds according to IUPAC system. So that in the last lecture we have studied. Today we have to study about effective atomic number, and after that we will study about the isomerism in coordination compound. Isomers shown by the coordination compounds. So isomers shown by the coordination compounds are different types that later we will study. But before it we have to study what is effective atomic number and how to calculate the effective atomic number of metal ions in a coordination compound, coordination complexes, that we have to study. As we have studied we know Werner's theory for complexes, and Sidgwick actually derived the formation of coordination compound, how it takes place, and stability of coordination compound is explained on the basis of the effective atomic number. यानी क्या coordination compound is stable or not stable, it is decided from this effective atomic number. So what is effective atomic number? See, first of all, the total number of electrons around the central metal ion, in a coordination complex, in a coordination compound, that is known as effective atomic number, which is abbreviated as EAN, that is effective atomic number. So total number of electrons present around the metal ion in a coordination compound, so that is known as the effective atomic number. What happens if that is the effective atomic number in a coordination complex, metal ion attain nearest to noble gas electronic configuration, that is to attain the stability. If effective atomic number of metal ion is equal to 18, that is nearest noble gas electronic compression is like to that of the argon, or if it is 36, that is krypton. If effective atomic number is 54, that metal atom or metal ion, the electronic compression like to that of the xenon, or if it is like to that of the like to that of the radon, then its effective atomic number will be 86, and then the metal atom satisfy effective atomic number. It is to be said that effective atomic number rule is satisfied when effective atomic number of that metal ion is equal to the nearest noble gas electronic compression, like the argon means effective atomic number is equal to 18, or nearest noble gas electronic configuration of that metal ion is equal to 36 number of electron around it, then it satisfies the effective atomic number rule. If that metal have exactly equal to number of electron is equal to the nearest noble gas electronic configuration, then it satisfies the effective atomic number rule. Now see, effective atomic number is equal to Z minus X plus Y. This formula here you have to learn and remember to find out the effective atomic number of metal ion in coordination compound. So effective atomic number is equal to Z minus X plus Y. What is Z? Z is atomic number of metal. Atomic number of metal. X is the number of electrons lost by metal to form metal ion, and Y is the number of electrons donated by ligands to metal or metal ions. So that is nothing but the effective atomic number formula. To find out the effective atomic number, formula is Z minus X plus Y. What is effective atomic number? Total number of electrons present around the metal or metal ion in a coordination compound or coordination complex. यानी क्या coordination compound में, coordination complex में metal ion के बाजू में, सराउंड में, अराउंड में टोटल इलेक्ट्रॉन्स कितने हैं, ये फाइंड आउट करते समय we have to take an account the number of electrons of that metal ion. So number of electrons of metal ion, how will you find out? Total number of electrons of that metal minus number of electron lost by that metal to form that metal ion, और b electrons metal ion के बाजू में और सराउंड में है, वो कौन से लिगैंड्स क्या करता है कि मेटल आयन को इलेक्ट्रॉन डोनेट करता है, और मेटल आयन को इलेक्ट्रॉन डोनेट करने के बाद वो लिगैंड्स मेटल आयन के साथ कोऑर्डिनेशन कंपाउंड, कोऑर्डिनेशन बॉन्ड फॉर्म करता है. सो वी हैव टू टेकन इनटू अकाउंट एटॉमिक नंबर ऑफ मेटल माइनस नंबर ऑफ इलेक्ट्रॉन लॉस्ट बाय मेटल टू फॉर्म मेटल आयन, एंड हाउ मेनी इलेक्ट्रॉन डोनेटेड बाय लिगैंड्स टू मेटल और मेटल आयन. So that is taken into account, and we will take here some examples to find out the effective atomic numbers. Here you see this one example, that is first one, Zn Cn by 4, here 2 minus charge. First of all we have to find out, first of all we have to determine how many electron lost by that जिंक और मेटल टू फॉर्म मेटल आयन, यानी क्या उस जिंक की वो कोऑर्डिनेशन कंपाउंड में क्या ऑक्सीडेशन स्टेट क्या है. ऑक्सीडेशन स्टेट ऑफ दिस जिंक इज +2. हाउ? दैट इज -4 इक्वल टू -2 एंड -2 + 4 इट इज +2. यानी क्या इस कॉम्प्लेक्स में जिंक ने 2 इलेक्ट्रॉन लॉस किए, 2 इलेक्ट्रॉन लूज किए टू फॉर्म द मेटल आयन, एंड देयरफॉर हियर सी इफेक्टिव एटॉमिक नंबर ऑफ जिंक इज इक्वल टू Z minus X plus Y. एटॉमिक नंबर ऑफ जिंक इज 30. इसने 2 इलेक्ट्रॉन लूज किए -2, और एक साइनाइड 2 इलेक्ट्रॉन डोनेट करता है. कितने? 2 इलेक्ट्रॉन, क्योंकि एक साइनाइड आयन एक लोन पेयर डोनेट करता है जिंक को. सो 4 cyanide ions will donate 8 electrons, and this will be 28 plus 2 equal to 36 is the effective atomic number of zinc in this example. That is the effective atomic number of zinc in this example is this one. 36, which satisfy the effective atomic number rule. Here you see the next one example, that is CONH3 by 6, and charge on this complex is plus 3. Now we have to find out the effective atomic number of cobalt. Effective atomic number of cobalt. So for that we should know what is atomic number of cobalt and what is the oxidation number of cobalt. Atomic number of cobalt is 27, and if all neutral ligands are attached to central metal atom or ion, then the charge on coordination pair is equal to oxidation number of that metal ion, or oxidation number of metal ion is equal to charge on it. Therefore, effective atomic number of cobalt in this complex Z minus X plus Y, atomic number of cobalt is 27. Minus how many electron lose by cobalt to attain plus 3 oxidation number? 3 electron. It is 27 minus 3 plus 1 ammonia molecule donate 1 lone pair of electron to cobalt. So 6 ammonia molecule will donate 6 pair of electron. Pair यानी क्या इलेक्ट्रॉन कितने हो गए? 12. So here 27 minus 3 plus 12 is equal to 24 plus 12, and which is equal to 36. So that is the effective atomic number of cobalt, 36. So it also satisfies the effective atomic number rule, because its effective atomic number is equal to atomic number of nearest noble gas. See the another one example here we have to take, that is the NiCO by 4, and we have to find out effective atomic number of nickel. The atomic number of nickel is 28 minus, there is no charge on nickel, means oxidation number of nickel is 0, क्योंकि ये सब न्यूट्रल लिगेंड अटैच है निकेल को और इसके ऊपर भी कोई चार्ज नहीं है, तो इसमें ऑक्सीडेशन नंबर निकेल का 0 आता है, 0. So 28 minus 0 plus 1 carbonyl group donate 1 lone pair of electron to nickel. Therefore 4 carbonyl group will donate 8 electron to it, and therefore it is plus 8, and this is also 36, which satisfy the effective atomic number rule. Then see the next one example. Here we have to take Cu, then what, that is the NH3 by 4, and here 2 plus charge. Obviously we have to find out effective atomic number of metal ion present in that complex, metal ion present in that coordination compound. Here the effective atomic number of copper is equal to same formula Z minus X plus Y. Atomic number of copper is 29. Now this is the oxidation number of copper. Why? Because all ligands, if neutral ligands attached to central metal atom or ion, अगर सब लिगैंड जो अटैच है सभी अगर वो लिगैंड्स न्यूट्रल है, तो व्हाट इज द चार्ज ऑन कोऑर्डिनेशन पेयर? It is nothing but the oxidation number of that copper or metal atom or ion, and therefore here it is what, that is the minus 2 plus 8. 8 क्यों? क्योंकि एक अमोनिया मॉलिक्यूल 2 इलेक्ट्रॉन डोनेट करता है, एक अमोनिया मॉलिक्यूल 1 लोन पेयर ऑफ इलेक्ट्रॉन डोनेट करता है, तो 4 अमोनिया मॉलिक्यूल 8 इलेक्ट्रॉन डोनेट करेगा, और इसका इफेक्टिव एटॉमिक नंबर विल बी 35, and 35 is not atomic number of any real gas or noble gas element. 35 एटॉमिक नंबर किसी भी रियर गैस और नोबल गैस का नहीं है, तो दिस copper in this complex does not satisfy the effective atomic number rule. You don't forget that. Satisfy means its effective atomic number rule. Number should be equal to that of the atomic number of nearest noble gas. मगर इसमें क्या होता है, इफेक्टिव एटॉमिक नंबर कॉपर का 35 आया है. 35 किसी भी नोबल गैस का एटॉमिक नंबर नहीं है, तो ये कॉपर ये इस कॉम्प्लेक्स में इफेक्टिव एटॉमिक नंबर सेटिस्फाई नहीं करता, मगर इसका इफेक्टिव एटॉमिक नंबर 35 है. सी द नेक्स्ट वन एग्जांपल. आई वुड लाइक टू टेल यू द सेम टाइप, दैट इज Fe Cn/6, and here what that is the, we will take 3 plus. Now effective atomic number of ion Z minus X plus Y, atomic number of F is 26. कितने इलेक्ट्रॉन लूज किए? 3, and here 12. Here it is what that is the 23 plus 12. इसमें भी कितना आ गया? 35. और ये भी इफेक्टिव एटॉमिक नंबर को सेटिस्फाई नहीं करता, तो इसमें some exceptions are there. Some exceptions are there which does not satisfy the effective atomic number rule. So these are nothing but the effective atomic number rule of some of the metal ions in a complex. So yourself also you have to take some more examples of coordination compound and find effective atomic number of metal in that complex. So this is about effective atomic number, that is EAN, total number of electron present around the central metal atom or ion in a coordination compound, in a complex compound, is called as effective atomic number. Now see the next point here we have to study, that is isomerism. Isomerism in coordination compound. So isomers of coordination compound is very important point, because coordination compounds are the compound which shows many types of isomers. Much more type of isomers are shown by coordination compound or the complexes. You see a chart in which we get an idea about the types of isomers of complexes or coordination compound, that is isomers. Mainly there are two types of isomers of complexes or coordination compound, that is stereoisomers and structural isomers. Stereoisomers and structural isomers. Structural isomers are also called as constitutional isomers. Constitutional isomers. Now again, stereoisomers are of two types. Geometrical isomers. Geometrical isomers are also known as distereomers. They are also called as distereomers. And optical isomers, that is the enantiomers. About the optical isomers, we have studied in haloalkanes and arenes, that is the enantiomers. Enantiomers means there are non-superimposable mirror images of each other. Compound have same formula, but they are non-superimposable on their mirror images. So they are called as the enantiomers, or they are also known as the optical isomers, optical antipodes also. And second type of isomers, structural isomers of coordination compounds, are of 4 types. That is linkage isomers, coordination isomers, ionization isomers, and the solvent isomers. Solvent isomers. So we have to study one by one in detail with examples about the what that is the isomers or isomerism of coordination compound. So see first of all stereoisomers of coordination compound. Stereoisomers means what? That is the spatial arrangement of ligands in the space of that molecule, coordination compound or complex around central metal atom, around the central metal atom or ion. So that is nothing but the stereoisomers. That is the stereoisomers. Stereo, what is meant by stereo? Means having same formula, but it forms two type of the representation. क्या होता था पहले के जमाने में? स्टीरियो साउंड सिस्टम, ऐसा एक टेप रिकॉर्डर था। उसको स्टीरियो साउंड सिस्टम क्यों कहते थे? क्योंकि दो साइड को दो स्पीकर होते थे वो टेप रिकॉर्डर में, और उसको साउंड जो प्रोवाइड करने वाली सिस्टम थी वो एक ही थी। सो दैट इज द स्टीरियो साउंड सिस्टम। अपने इस केमिकल कंपाउंड के बारे में यू हैव टू अंडरस्टैंड एंड you have to remember like this in case of complex compound. कंपाउंड एक ही है, कंपाउंड का फार्मूला भी एक ही है, मगर दो तरीके से उसे रिप्रेजेंट कर सकते हैं, उसे दो टाइप से रिप्रेजेंट कर सकते हैं। सो दैट इज नथिंग बट द स्टीरियोआइसोमर्स। ओके, अगेन द स्टीरियोआइसोमर्स आर ऑफ टू टाइप्स, दैट इज द geometrical isomers, geometrical isomers, or they are also known as the distereomers. They are also called as the distereomers. Now about this distereomers, here we have to study, that is the geometric, these are non-superimposable mirror images, no doubt, but here in this case these are the isomers due to the spatial arrangement of the ligands around central metal atom or ion. So that is nothing but the geometrical isomers. Central metal atom और ion के साइड में जो लिगैंड की अरेंजमेंट होती है, वो लिगैंड की अरेंजमेंट करते समय दो टाइप से हम अरेंजमेंट कर सकते हैं। इसमें अगर दो टाइप्स की अरेंजमेंट होगी तो वो सीस आइसोमर्स एंड व्हाट दैट इज द ट्रांस आइसोमर। ज्योमेट्रिकल आइसोमर दो टाइप के हैं, सीस एंड ट्रांस, क्योंकि हमने अल्किन्स में सीखे हैं। सीस यानी क्या? टू सिमिलर एटम, here two similar ligands are present on the same side of central metal atom or ion. और trans यानी क्या? Two similar atom, two similar ligands are present across opposite side. So that is nothing but the trans. यानी कि geometrical isomers में दो टाइप के आइसोमर्स हैं, cis isomers and trans isomers। हमें पहले geometrical isomers in square planar structure स्टडी करना है, that is the geometrical isomers in square planar complexes, so that first of all we have to study square planar complexes यानी क्या? उस कॉम्प्लेक्स की ज्योमेट्री, उस कोऑर्डिनेशन कंपाउंड की ज्योमेट्री स्क्वायर प्लेनर है। ओके, स्क्वायर प्लेनर कॉम्प्लेक्स में इस टाइप के एग्जांपल होते हैं M(A)to(B)2 एंड M(A)to(BC टाइप ऑफ कॉम्प्लेक्सेस शोज द ज्योमेट्रिकल आइसोमर्स। यहाँ A and B are monodentate ligands. A and B are monodentate ligands. इधर A और B monodentate ligand, यानी कि यम मेटल एटम और मेटल आयन, टू सिमिलर टाइप ऑफ monodentate ligands and two similar type of monodentate ligands, मगर A और B डिफरेंट ligands है। इसमें A2 यानी कि दो सिमिलर ligands है और बाकी के दो अगर अगेन दे आर डिफरेंट देन द B and C are also different. So we have to study in detail the coordination complex of M(A2B2) type of ligands, how they shows the geometrical isomers. So that we have to study. Here by taking the example of M(A2B2), and after that we will take the example of M(A2BC) type of ligand, coordination complex and their geometrical isomers actually we have to study. Here see, for example, first one, that is the cisplatin. So formula of cisplatin is Pt NH3 here by 2 and Cl2. This is nothing but the A2 यानी कि दो अमोनिया मॉलिक्यूल, B2 दो क्लोरीन एटम किंवा क्लोराइड आयन्स और क्लोराइड आयन्स. So here see, in the square complex platinum is present at the center. Here chlorine, here one chlorine atom is there, here ammonia molecule, and here also one ammonia molecule is there. Here this is nothing but the coordination compound, and this isomer is cis isomer, so called as cisplatin. It is cis isomer क्योंकि इस आइसोमर में दो क्लोरीन एटम सेम साइड को है और दो अमोनिया मॉलिक्यूल भी सेम साइड को है. Therefore it is cis isomer. This is cis isomer. Now by using the same formula we can write this square complex like this. Here chlorine, here NH3, and here also NH3. This is the another isomer, and this isomer is what, that is the trans isomer. It is trans isomer. ये ट्रांस आइसोमर क्यों है? क्योंकि इसमें जो सिमिलर लिगेंड है वो सेम साइड को नहीं है, क्रॉस है, क्रॉस अपोजिट साइड को है. अमोनिया भी अपोजिट साइड को है. सो इट इज द ट्रांस आइसोमर. दिस इज ट्रांस आइसोमर. नाउ सी द सेकंड टाइप, second example to study the coordination isomer, that is the platinum. Okay, then Cl2, NH3, and what, that is the H2O. You see, M यानी कि platinum, A2 यानी कि दो लिगेंड सेम है, मोनोडेंटेड दो लिगेंड सेम है, और इसमें जो another two ligands है, they are different. They are not same, they are different. So A2B and this is C. Okay, so it is M(A2BC) type of the coordination compound or the coordination complex, and we have to write it cis and what, that is the trans isomer. You see here platinum is present here, then here what, that is the H2O, here NH3, here it donate electron pair to central platinum. Therefore you can write in this way bond by using arrow facing towards the platinum. So two chlorine atom present on the same side, so it is cis isomer. And here platinum, here chlorine, here H2O, and this is what, that is the NH3. Here this is nothing but the trans isomer. It is the trans isomer. So this is nothing but the geometrical isomers in square planar complex, that is two chlorine atom across, so therefore it is trans isomer. Two chlorine atom on the same side, it is cis isomer. So you can write this bond like this facing arrow towards the platinum or metal, which shows that coordination bond formation. This is nothing but the geometrical isomers in square planar complex. Now geometrical isomers in octahedral complexes also we have to study. Cis and trans isomers in octahedral complexes. Next point, cis and trans isomers in octahedral complexes. Octahedral complexes. So that we have to study. Cis and trans isomers in octahedral complexes. Now octahedral complexes are of various types. Generally how they are represented, or उसके बाद we will take specific examples and then we will show the cis trans isomers in that octahedral complexes. So see, first type, it is of MA4B2 type, MA4BC type, that is the MA4B2, MA4BC and MAA by 2, what that is the B2. Types of complexes or coordination compounds are there. Same way, A and B are monodentate ligand. And what is the meaning of AA by 2? Here this is the chelate ligand, bidentate ligand. So when you are to represent a bidentate ligand, double A, यानी कि bidentate ligand, double B, मगर that BB is different than that of the AA. So such type of ligand can shows the cis trans isomers. They shows the cis trans isomers. Now here see, for example, here what that is the CO NH3 by 4 Cl2. You see cobalt M, A4 NH3 by 4 and B2 Cl2. That is nothing but the complex. Here charge on this complex is what, that is the +1 charge is there. And how will you write the cis and trans isomers of, you see, cobalt is present at the center, 1, here 2, here 3, 4, 5 and 6, here fluorine and 4 ammonia molecules are attached to the central cobalt ion.